Okay, for this review, since this was made by one of my colleagues, I will go through it, and you can pick whatever parts you want to watch. So in problem number 1, it asks for the vertical shift. Well, that's easy enough. The vertical shift is always the last, which is -7. Just in case they ask other questions, the amplitude is equal to 3. The period is equal to 2 pi divided by k, which is 2, which is pi. And the phase shift is when you set what's inside parentheses, which in this case they already factored for us, equal to 0, so x equals pi over 4. For problem number 2, write an equation that has an amplitude of 2 and a vertical shift of 2 and no reflection over the x-axis. Well, they didn't tell us what to use, so I'm going to use sine. And if it has an amplitude of 2, then it could be plus or minus 2 in front. And 2 units up is a plus 2 at the end. And since it didn't say anything about a phase shift or a period change, we're going to leave it like this. For problem number 3, we have y equals the cosine of 3x, and they want to have a inverse. So the first thing I do is I switch x and y. Now, because the cosine is on the outside of the parenthesis, the first thing I'm going to do is arc cosine, or cosine -1 of both sides. And then I'm going to divide both sides by 3. And so the cosine, a little inverse cosine of x divided by 3, where divided by 3 is not in parentheses, would be my answer. For problem number 4, it has 3 different questions. It asks where the sign is negative, so let's just do the all students take calculus. And where the sign is negative is in quadrant number 3 and quadrant number 4, because I should do 1, 2, 3 in IV, Roman numerals, because that's where everything's positive in 1 and sign's positive in 2, so 3 and 4. The cosine would be in quadrant number 2 and quadrant number 3, and the tangent would be in quadrant number 2 because that's where the sine is positive, and quadrant number 4 because that's where the cosine is positive. For problem number 5, they're asking a problem where the sine is negative and the cotangent is positive, but I don't know much about the cotangent, so I'm going to say the tangent is positive because the reciprocal is positive. So the tangent is positive in quadrant number 1 and quadrant number 3, and we just saw that the sine was negative in quadrant number 3 and quadrant number 4. So the only thing that works with both of those blue circles is quadrant number 3. For problem number 6, they start us off with the cotangent is equal to 4/5, which means I'm going to change this to be the tangent is equal to 5/4. And they said it was in between pi and 3 pi over 2. So that means we're in quadrant number 3, because 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I put it in here, and the tangent is 5/4, which is the opposite over adjacent. So in order to find out what the secant is, I'm going to do 5 squared plus 4 squared equals c squared. So I get 41 is c squared, so this turns out to be the square root of 41. Now, in our formulas, it will tell us that secant goes with cosine. And by the way, I forgot that this should be a full -4 and -5 because we are left and down. So the adjacent is -4 over the hypotenuse, which is the square root of 41. So the secant of theta is going to turn out to be the square root of 41 over negative 4, and really the negative can be anywhere just so long as the answer is negative. Alright, so number 7 has the cosecant of theta, sine of theta, cotangent of theta, secant of theta, and we're trying to simplify it. So cosecant is 1 over sine, and we got the sine, and we got the cosine over the sine, and we got the not cosine, we got 1 over the cosine for secant, because it's always easiest to simplify with sines and cosines. So this sine and this sine cancel, and this cosine cancel, and so the only thing we have left is a sine in the denominator, which is the same thing as cosecant theta, so my answer is cosecant theta. Problem number 8 has another one. Secant theta, tangent theta over sine theta. So 1 over cosine theta times sine theta over cosine theta divided by sine theta. So since this sine is in the numerator and this sine is in the numerator of the denominator, they can both be canceled out, and so I'm left with 1 over cosine squared theta, because cosine times cosine is cosine squared theta, which simplifies to be secant squared theta. Secant theta is equal to the square root of 15 over 2 in the quadrant number 4. So the cosine of theta is equal to 2 over the square root of 15. So 2 square root of 15. So 2 squared plus b squared equals the square root of 15 squared. 4 plus b squared equals 15. So b squared equals 11. So b equals the square root of 11. Now this problem, I made a mistake on, because the 2 should be here, because it was cosine, and that should be negative square root of 11. So instead of getting the cotangent right away, I'm going to get the tangent, which is the opposite over the adjacent, which means the cotangent is equal to the adjacent over the opposite, and there's my answer. Number 10, we have 2 sine x plus the square root of 2 equals 0. So 2 sine x equals negative square root of 2, divide both sides by 2, and the sine of x equals negative square root of 2 over 2. Based on what we've done in previous problems, we should know this is in quadrant number 3 and quadrant number 4. Now in my calculator, I'm going to make sure my mode is in degrees, because this problem is asking for degrees. So when I do inverse sine of, and I'm just going to use positive square root of 2 over 2, it's going to tell me the answer is 45, which means this reference angle is 45 and this reference angle is 45. So when I go around that way, that's 45 plus 180, which is 225. This one is 45 front 360 minus 45, which is 315. I'm going to do 10 problems on each video to make it easier for you to find. So that's it for this first video.